There is a natural mechanism, though, for unfreezing the Earth if it gets totally covered with ice, but only if it has plate tectonics. So here's the mechanism. Suppose the Earth gets so cold that it freezes everywhere, all the way down to the equator, and the oceans. So the snowball Earth is what we call that. That actually has happened. We have had the Earth in a snowball Earth situation 3 different times. Fortunately, it won't last, because once you've cut off the atmosphere from the ocean by putting a layer of ice between, then the CO2 that is generated in volcanoes that goes into the atmosphere can't then go into the ocean. And so the CO2 in the atmosphere will build up, and it'll build up because it's got nowhere else to go. But CO2 is a greenhouse gas. So the more greenhouse gas comes in from volcanoes, the hotter your planet, until finally you've melted it, and then now the CO2 can dissolve into the ocean and go back into some form of stability. So the greenhouse gas cooling must match stellar luminosity heating rate. Stars differ in the rate at which they warm up. They warm up faster, much faster, if they're more on the early G or late F type of spectral type, and they warm up much slower if they're in the late G or K type spectra. So only if you can show convincingly that this will be tuned by life, that life will ensure that you make the rate at which we shed layers exactly match that which we need to keep climate constant. Can you say that, well, this number should just be 1 and let's not worry about it? I'm not convinced that it really is 1. I'm not convinced by the Gaia hypothesis. I think things can go wrong. They didn't go wrong on the Earth, but that's not to say they couldn't have. So I'm going to give this a number. I won't knock it down too much, okay? So we'll Gaia it a little bit. We'll call it 0.8. Okay, well, now we got another problem. What about no low-order resonances with other planets? So a long-lived, stable orbit. Again, climate stability. We need our planet to not get turned elliptical. We need another planet not nearby to get elliptical enough and get close enough to then cause us to lose our orbit and go off into the wild blue yonder. That can happen even with circular orbits if the orbits have a low-order resonance. So we may have solved the circular orbit problem, but we may still have trouble, because if you go around 3 times for every twice that a planet just beyond you goes around, you're going to get tugged at the same point in your orbit over and over in the same direction. And little tugs add up. It's exactly like pushing somebody on a swing set. You push them at just the right moment at the bottom of their swing, you can get their swing to amplify. We all did that as kids in the playground. Fun, fun, fun. Not so fun if you're on a planet and you want stable climate. Okay, we see non-migrating orbits all over the place. We see orbital migration being very common in other solar systems. All those hot Jupiters out there, we think, most likely formed far away and then migrated in. There are some people trying to figure ways that we could make them in and keep them in and not evaporate away, but not sure whether that's going to stand scrutiny. There's some just really recent work on that I was hearing about. It's easier to get resonances than not. Just look at Saturn's rings. There's resonances all over the place. That's why Saturn's rings are thousands of little teeny ringlets. Okay, it's not like there's a gap just in a few places. There's gaps everywhere. So we seem to have been very lucky in our solar system to not have any orbital migration going on in the orbits of the inner planets, and maybe even not much with Jupiter. So I have to knock our number down quite a bit, 0.2. We were lucky. Okay, so here's a new paper, Schwieterman et al. In 2019 have refined the habitable zone with a new understanding of the necessary CO2 and possible carbon monoxide, you don't want that, to keep planets warm in the outer regions of the conventional habitable zone. Higher CO2 levels, not good. The levels of CO2 necessary to warm the planet by the greenhouse effect at the cold distances of the outer solar system. Okay, let me pause a moment. It's also true that once I get wound up teaching, I can't stop. I can't stop myself. Increasing high CO2 levels lead to increased carbon monoxide by dissociation. And carbon monoxide is extremely toxic. We have hardly any CO2 in our atmosphere. 400 parts per million, that's hardly anything. We don't have to worry about CO. But if we had 10 times or 100 times or 1,000 times that level in our atmosphere, well, that'd be big problems. So I'm sorry, I have to knock our habitable zone down from recent work. Note problem, possibly the sun passing through spiral arms in our galaxy. The odds increase for nearby stellar passages disrupting the Oort cloud of comets, resulting in comet impacts. Also, the odds of fatally close Type 2 supernovae go up. While it's not clear exactly how high these odds are, the calculated odds of disaster are comparable to observationally constrained estimates. It's probably not a big problem. We have made 20 orbits of the galaxy so far. It does look like, though, that maybe, again, we were just really lucky. Here's this great paper by Lepine et al. In 2017. It shows that the sun is in a small region between two spiral arms near the co-rotation resonance radius of the galaxy. This is such that it keeps the sun's orbit confined to regions which keep us from ever entering a spiral arm. So this is a danger we've never really had to face. Very lucky. There's where we are. We're right there. We're between the Sagittarius arm and the Perseus arm. And these are... Anyway, this is too wonky. I'm going to keep going. We're in a lucky place. A lucky place. If we stay in here, we can just keep migrating around in here, and we don't end up in the spiral arms where there's a lot of supernovae going off. You don't want a supernova going off too close or it'll sterilize your planet. So we can't apply the 1 factor for GK main sequence stars formed per year for the suitable stars. This is new work. It looks very significant. It looks very important. I'm going to have to knock that number down quite a bit. Only 15% now. Again, somebody can prove me wrong. Be my guest. I would love to be educated. Anthony and Sierra. But we are going to come up with a really interesting conclusion, and there it is. When you multiply all these numbers together, what do you get? You get 0.1 intelligent civilizations in the galaxy. So if we round that up to 1, that's us. 1 civilization in the galaxy. Now, this agrees with our observations and would resolve Fermi's paradox, but admittedly, they're very dependent on these very uncertain guesstimates that I've put in. So this is, could this be off by a factor of 10? Oh, easy. 100? Oh, easy. 1,000? I don't know about 1,000. Maybe. But I do think that the original optimistic, simplistic numbers of the Drake equation are definitely too optimistic. I don't have any doubt about. Well, let's assume, though, that maybe that number, that 0.1, is too pessimistic. Maybe there's really at least a dozen out there, and that some of them have had enough civilization to have found us, seen, oh my God, here's a planet And it's got both oxygen and methane in the atmosphere. Frankly, technologically, we think we'll be able to do that, at least in some form, in just a few years. And in 100 years, I mean, assuming we don't kill ourselves, that should be easy. We should have good enough chronograph-equipped telescopes and big enough telescopes in outer space that we could do that. With planets, stretching from here to, a good chunk of the galaxy. So I think it's highly unlikely that there's an advanced civilization out there, 1 million years advanced of us, that doesn't know that we're here, that we are a living planet. I find that very hard to believe. So then we got to ask, where are they? This is Fermi's paradox. So some of this is kind of fun. I hope you stick with this. I got some fun slides. So Fermi's paradox is a puzzle if you think galactic civilizations are, if not common, at least a lot more common than the number I just derived. The Area 51 nonsense, X-Files nonsense has been debunked. Okay, we don't have to go there. Do you really believe E.T. is going to kidnap Farmer John and his wife so that they can have their evil sexual experiments on them? Probably not. The level of intelligence of E.T. suddenly shrinks to the level of Farmer John. So that's the problem with most of these accounts. But it's true, we don't see any monoliths on the moon. We don't see any monoliths out near Europa, like in the movie. SETI's listening to radio waves from lots and lots and lots of stars over billions of quantum frequencies simultaneously. So far, they've heard nothing. If they wanted to talk to us, they certainly would have made it easy for us to find them by now. That's the takeaway that I want you to get from this slide. It's all those F factors after the original Drake equation that may be the answer. So maybe microbe life really is common, but intelligent life may be so rare that maybe we really are unique. But still, let's try and be optimistic one more time. Maybe they really are out there. How could they be out there but they don't want to talk to us? Maybe they're obeying the Galactic Prime Directive, the Federation, remember from Star Trek. Don't disturb the natives. Well, maybe, but if there's thousands of civilizations and not a single one is curious enough or has enough compassion, after all, we could use some help here. I think you have to agree. Or greed. We are on a pretty juicy planet. We decided that. Not one of these thousands has decided to break the Prime Directive and either come save us or else exploit us. I think that's a little unlikely. That's just my feeling. Maybe they're watching. Maybe they're waiting and plotting silently and will soon arrive and take over our planet for themselves. Maybe country music is all that will save us. Now that's a grim thought. Okay. Thank you, Sierra, for laughing. I try to leaven things wherever I can. Sometimes it's black humor, but, I do my best. So modern civilization has its horrors, but not like the Dark Ages of the Old Testament yet. So I think that as civilizations get more advanced, they tend to solve more problems. They tend to get less greedy, less avaricious, less psychologically damaged, and more likely to be benevolent and have goodwill. So maybe they're just not wanting to talk to us because they know if they did, then it would just mess our whole civilization up. I don't know. We're on the ragged edge of killing our planet here with another mass extinction. I think we could use a little help, frankly. I So, okay, before we lay out the welcome mats, Gerard O'Neill observed that in every case when Western civilization encountered a primitive culture, that other culture was the one that suffered or even went extinct. So in any encounter between us and the aliens, we are the primitive culture, because how long have we been in interstellar civilization? Well, for only, 100 years? Depends on how you want to define it. How long have we even been a species? Only 1,000,000 years. So if they're midway in their time period as well, and 1,000,000 is after all not much compared to the billions of years that has been around. So my guess is we're probably about the most primitive of the interstellar capable civilizations. So maybe they don't want to talk to us because they don't want to disturb us. So, but then we have to say the other side. I mean, the Earth is an amazing place, covered with life. It's got just the right amount of water, the right amount of continents, stable climate, chock-a-block with life everywhere, a beautiful, stable sun that's going to be good for hundreds of millions more years, no toxic solar flares, and, it's great. It's a great planet. Talk about real estate. This is prime real estate. So why are they letting humans wreck this ultra-rare planet and not doing anything about it? That, I find, is one of the more perplexing questions. More perplexing even than Fermi's paradox. In total, is this more refined question. Why are they letting us do this to our planet? Why aren't they already here to terminate us so Earth can live? Dissolving us with their deadly nanobots. Or at least shocking us with their outrageous attire. Okay, well, now that's an actual real micrograph. And when I first saw this, I could only think of those deadly nanobots in The Day the Earth Stood Still. I'm having a little fun with you, though. These are reasonably well known to be viruses of a certain kind. But they are kind of spooky looking, aren't they? I mean, it looks like somebody manufactured these things with little legs, and they just wander around and they poke this thing into you, and then God knows what happens to you. You turn into like those people who went up onto the sandy hill and the invaders from Mars, and they got those things stuck in their necks, and then they became like zombies. That was the scariest movie I ever saw when I was 5 years old. Anyway, okay. You want to read more about some of the things that I talked about here? Read Peter Ward's Rare Earth. So I confess I haven't actually read Rare Earth. I've heard him talk, and I know the basic ideas, but I tried to be as independent as possible when I did this. And Here Be Dragons is also a great book. So if they come, will they like us? It depends on who they meet, I'm thinking. I'm not going to play this video for you. It's kind of both cuttingly humorous and also disturbing. But I would encourage you to click on it, and it's a pretty unvarnished look at how mankind relates to its fellow species on this planet. All right, that is it for this lecture. Thank you for making it to the end. I will post this on YouTube. I might have to post it in 2 parts. I'm not sure. This is now